Okay, so now we're going to look at solving systems of equations. So remember, you have three types of solutions. You have one solution, no solution, or infinitely many. One solution is going to be where your lines intersect at a common point. And so you're looking for that specific x and y value where the two lines intersect. So it's the common x and y value that they have. So you really have two answers when your lines intersect. You have an answer for x and an answer for y. No solutions would be when your lines are parallel, because parallel lines are never going to intersect and therefore never have a common x value and y value. And then infinitely many solutions is going to be when you have the same line, meaning that they have the same slope and they have the same b, the same y-intercept value. Okay? So that means that the lines are going to overlap and they're going to share every single point, and there's too many ordered pairs to list out because every ordered pair is a common point for those. So there are actually three ways that you can solve a system of equation. The first way is to graph. So it's called graphing. And that's where you put both equations in slope-intercept form. So you're going to do y equals mx plus b for both and then graph and see where they intersect. Isolating a variable in one equation and substituting into the other, so that's called substitution. And the final way to solve a system is through elimination, where you line up like terms and you eliminate a variable. Now, the most common that you're going to be able to use, and the one that's kind of like your safety net, is graphing, because if they give you an equation, or you can get an equation from your calculator, then you can graph them and then you can see where they intersect and then look at your options. So look at example 1. So eventually these lines are going to intersect. So what I'm going to do is I'm actually going to write both equations to find the solution. So on line number 1, which I am going to highlight yellow so that I can keep everything straight, I am going to find the slope of this line, and so I need an ordered pair. So this looks like a good ordered pair, and this looks like a good ordered pair, so that would be 4, 3. And this ordered pair is going to be -2, 0. Okay, so if I find the slope very quickly, I can see that my x values are 3 and 0. And then my y values are 3 and 0. My x values are 4 and -2. So I'm going to get my calculator real quick, and I'm going to type this in. I'm going to do stat enter. Nope, not stat enter. I'm just going to type in my fraction, and I'm going to say 3 minus 0 is divided by 4 minus a -2, so that's going to give me a slope of 1/2. Okay, and then I need a y-intercept, so my y-intercept for this equation is going to be 1. So I already know my equation is going to be 1/2 x plus 1. So I'm actually going to write that over here. So I'm going to say y equals 1/2 x plus 1, and I'm actually looking for my second y equals equation, which is going to be this pink line right here. And again, I need a slope, so I'm going to need two ordered pairs, and it looks like it crosses here and here, so I'm going to have a point at 3, 0, and a point at 0, -3. So now I'm going to find my slope. So I need y values. Y values is going to be 0 and -3, and then my x values are going to be 3 and 0. So I'm going to get out of this. I'm going to go back to my screen. I'm going to type in my fraction, and I'm going to type in my slope, 0 minus -3 over 3 minus 0, and that's going to give me a slope of 1. And then I need a y-intercept, and I can clearly see that it crosses at -3. So I know my equation is going to be 1x, or just x, minus 3. That would be my system of equations. And so now I'm going to go back to y equals, and I'm going to add this second equation. So I'm going to go down to y2, and I'm going to type in x minus 3. And now I'm going to graph it. I'm going to see if I can see where they intersect. So there's y1, and there is y2. Now I can get a little bit of help with the calculator. It looks like it's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, maybe 4 or 5. But if I want to get exact, I can go to second trace. And again, I'm looking for an option that's telling me where they meet. And the word for that would be intersect. So I'm going to pick option 5, and I'm going to hit enter for yes, I want to use that line. I want to use that line, and I want you to guess where they intersect. And it says that they intersect at the point 8, 5. That is the point that they have in common. All right, example number 2. It says y is equal to 5x plus 1, and then I have the equation 4 times the value of x plus the value of y is equal to 10. So I'm going to do exactly what I did over here. This time they gave me equations, so all I have to do is make them both in y equals format, and you can see the first equation is already in y equals format. So now I'm going to rearrange the second one, and all I really have to do to get it in y equals is to move the 4x, and I've got to decide, do I add or subtract 4x to both sides to move it, and I'm going to subtract. So I'm going to get y equals 10 minus 4x, and then I'm just going to copy down my other equation, y equals 5x plus 1. And again, it does not matter the order that you type the equations in, you just want to make sure that you have both equations in. So go to my calculator, and I'm going to go to 10 minus 4x, and then I'm going to type in 5x plus 1, and I'm going to hit graph. And I'm going to let my calculator graph this system to see where their common x and common y value is. And so it looks like it's at 1, 1, 2, 3, 4, 5, 6, maybe 6 or 7. So I'm going to do second trace again, and I'm going to have 5 be my option. And yes, I want the first equation, I want the second equation I typed in, and please give me an answer. And it says 1, 6 is their common ordered pair that they have in common. It's where they meet. Okay, if you have a table of values, here's what you're looking for. You are looking for a common point, common ordered pair that both tables have. So what I'm going to do is I'm going to see, okay, this has an x value of 0 and a y value of 7. Well, I don't see that in the point in the table for the second one, so I'm going to scratch this out. And again, I don't see 1, 6. So I'm going to scratch that out. And then when this has an x value of 2, this has a y value of 5. Well, I see 2, but this has a y value of 3. So I'm going to mark those ordered pairs out because those aren't common. They don't match. So now I'm going to look. When this x value is 3, this y value is 4. And when this x value is 3, this y value is also 4. So this would be a common point that they have in common. So the solution to this is going to be 3, 4. And you can also see that 4, 3, and 4, 5 don't match. And then 5, 6, and 6, 7 are in the second equations table, but not in the first, and they're not common. Alright, so let's look at special solutions. So again, I have a system of equations. I have the value of x minus the value of y is equal to 1. 3 times the value of x minus 3 times the value of y is equal to 3. So what I'm going to do is I'm going to make both equations y equals. So I'm going to start with the bottom one, and I'm going to move the 3x to the other side through subtraction. So I'm going to say negative 3y is equal to 3 minus 3x, and then I'm going to divide by negative 3 all the way through. And so that's going to give me y equals. And if I'm not sure about my division, I can always type this in. 3 divided by negative 3 is negative 1. And then I have negative 3 divided by negative 3. So a number divided by itself should be 1. So it's going to be a positive. So I've got to put plus x. And then I've got to rearrange the top equation. So I'm going to move the x to the other side. And how I'm going to move it is through addition or subtraction. And it's got to be subtracted. So I'm going to have negative y is equal to 1 minus x. And since this is a negative, it's really a negative 1y. So I don't want a negative 1y, I want a positive 1y. So I've got to divide by negative 1 all the way through. And I'm going to get y equals, because negative 1 divided by itself is a positive 1. This is going to be negative 1. And again, I have a negative 1 in front of the x, so negative 1 divided by itself is going to be a positive 1x. And so now I want to compare their slopes. So actually, I can just go to my calculator. I'm going to clear this out, and I can graph them. So negative 1 plus 1x. You don't have to type the 1 in if you don't want to. And then I've got negative 1 plus 1x. And I'm going to hit graph. And you can see there's the first equation that I typed in. And then if you look, you can notice on my color calculator that the red line for the second equation completely covers up the blue line, which is telling me that these are the same line. And if I do a little bit closer inspection, I notice that their slopes are matching. They have the same slope. And if I compare their y-intercepts, I'm also going to see that their y-intercepts also match. So if they have the same slope and the same y-intercept, that means that these are the same line. And if they're the same line, then that means that my answer is infinite solutions. Okay, infinite solutions. All right, so let's look at the last example. So I've got x is equal to y minus 1. So I could think of this as y minus 1 is equal to x. And if I wanted to solve this for y, all I have to do is move the 1 to the other side. Well, since it's being subtracted, I have to add it to both sides. So this is going to be y equals x plus 1. And now I need to rearrange the bottom equation. And all I need to do is I need to move the negative x to the other side. And because it's being subtracted, because of the negative sign, I would have to add it to both sides. So this is going to be y equals, that would end up being x minus 1. So now I'm going to clear my calculator and I'm going to type these in. So I'm going to go to y equals and I'm going to type in x plus 1 and then x minus 1 and I'm going to hit graph. So there's the first equation. Uh-oh. Let me type this in again. X plus 1. X minus 1. Something happened with my calculator. If something like this happens, just go back to your y equals and retype them in and hit graph. Sometimes things happen with your calculator. So there's the first equation. There's the second equation. And what are we seeing? We are seeing parallel lines. And if we remember parallel lines, they never intersect. They are never going to have a common point. So there is going to be no solution because they're never going to cross. So therefore, we're never going to be able to find an x value and a y value that they have in common. Another thing I want to point out is if you look at the slope of both lines, you're going to notice that they have the same slope. But if you look at their y-intercepts are not the same. So if you notice your lines have the same slope but different y-intercepts, you automatically know before you even graph that they're parallel lines and it's going to be no solution.